Okay, good morning. It's another time to learn, and we are on to Mambo with Jarvis. This is actually a live class, and I thought it wise to do this recording to help us improve on certain aspect of our mathematics. Our textbook of reference will be the New General Mathematics for SS1, and today we'll focus on an aspect of algebra that has to do with equations, and not just equations, not just any type of equations, but linear equations. And we'll be looking at an aspect of linear equations called algebraic fraction. So you see that there are three words in play here. There's one that talks about equation or equations. There's one that talks about what? Algebra or algebraic. And there's one that talks about what? Fraction. The word fraction would bring to our minds an aspect of maths called arithmetic. What's a fraction? A fraction simply is a rational number. A number that has a numerator and a denominator. For instance, this is a fraction. A over B or 1 over 2. These are fractions. A fraction would have a numerator and a denominator. A fraction can also be a type of decimal. A fraction is also a type of decimal. And by type of decimal, we would mean rational that is either terminating or what? Recurring. I will not go in details to look at this because that's not my focus for today. I would want you to look up my video on arithmetic. I've done a very extensive job there. So if you want to understand fractions, numbers, types of numbers and the likes, you can go to my video and look at that. That would suffice for that. But our focus today is to see how we can bring our knowledge of fractions into that of equations. What is algebra? Algebra deals with an aspect of maths that is concerned with two things: variables, unknown letters, and numbers. So the interplay of variables and numbers, or letters and numbers, is what we mean when we talk about what? Algebra. So the first thing I wrote here, A over B, is simply an algebraic fraction. It's simply what? An algebraic fraction. A over B. An algebra expressed as a fraction. That's what an algebraic fraction is. An algebra expressed as a fraction. Now, remember that that's not where we're going to. We are looking at what an equation is. And when we talk about algebra, there are two aspects to algebra. There is an aspect that tends towards expression, one-sided statements, and there is a part that tends towards equations, two-sided statements. Let's see if we can get a picture to what we're talking about. Now look at this. This is an expression. This is an equation. This is an algebraic expression. This is, if you want to say algebraic equation, but I will just simply say an equation. Why is it an equation? It means, the word equation means that it has two sides that are equal, which means that the value here is exactly the same as the value here. But that cannot be said of when we talk about an expression. So this is what we call an equation. This is what we call an expression. So put everything together. We will now go into our textbook to try to understand what an algebraic fraction being an equation would look like. Exercise 6C of our textbook, the New General Mathematics, page 79, would help us out in trying to handle problems relating to equations and algebraic fractions. So we'll take them one after the other and see for each question. Now, I always advise my students, when solving problems in maths, try to solve one to the next to the next. Avoid that tendency to, oh, I know number 1, I know number 2, okay, let me go to number 10. No, you really be doing yourself a lot of harm. So let's see how that plays out. Now we go to number 1. I'll just write the question on the board. X over 2 equal to x over 3 plus 1 over 2. X over 2 equal to x over 3 plus 1 over 2. So, how do you solve a problem like this? Very simple. Very, very simple. For a fraction or for any algebraic fraction, the one thing you must not forget is the concept of your LCM. When we're treating expressions, what the LCM does is different from LCD. Sorry about that. Let's be more technical. LCD. LCM, LCD, they're the same thing. But when it comes to fraction, you use the word or the term LCD, lowest common denominator. Now, if you look at this, with your study of mathematics thus far, we expect that you should be able to, by inspection, look at these numbers and tell what the LCD will be. And the LCD for this will be what? 6. Why? I have two denominators here, or 3 denominators with two of their denominators the same. I have 2, I have 3. So you have, if you go by our old school approach, which is something at grade 10 you are already way above. So the LCD will be 2 times 3, which will be what? 6. The LCD becomes what? 2 times 3, which will give you what? 6. Now, how do you apply the LCD in an algebraic equation? That's a fraction. That's what you need to take note of. We multiply through by the LCD. I'll come again. We multiply through by the LCD. That is to say, this LCD we have here, we'll use it to multiply this. Put in picture, this is what you're going to have. I'm only doing this for emphasis sake. And then what you have now will be this. I want to pay attention to this because when I solve others, I will not go through these steps anymore. Just wanted you to see what's actually happening in my head. So you cancel out. Mathematicians and agree that the strongest arithmetic tool a student should master is division. The strongest mathematical tool or operator a student should master should be division. You can't do away without it. You really need to master division. So this will give me what? So when you write that, that will give you 3x. How did I get that? 3 times what? X. Equal to 2 times what? X. Plus what? 3. 3 times 1. So what do? You collect like terms. That's the next important thing you need to take note of here. You do what? You collect like terms. Take note of the steps again. The first thing we did was to obtain what is called an LCD. And with the LCD, we use the LCD to multiply through the equation. If we treat algebraic if we treat algebraic expressions, the approach will be different. What we use the LCD to do will be quite different. But for an equation, we multiply that through. So this is what we're going to obtain. We've obtained this. The next important thing here is to do what? Collect like terms. I'm taking pains to explain this because once you get these steps right, it becomes very easy to solve any problem, irrespective of the level of what? Difficulty. So you do what? You collect like terms. For equations, we have a general rule. The unknown, the letters are kept on the left-hand side. The letters are kept what? On the left-hand side. The numbers are kept on the right-hand side. That's the essence of this arrangement. Keep the letters on the left-hand side, keep the numbers on the right-hand side. So let's see how that works out. Now, this becomes 3x minus 2x equal to 3. Now the next question, students will usually ask questions. Why is this so? Now, in your grade 8, which is called JSS2, you would have been taught a topic called balancing method. The objective of balancing method was to show the reason why when we move this to the other side, it becomes what? Negative. If this crosses equality, I'm trying to use colloquial language now, not official. I'm trying not to be too official now. If you move this to the other side, it becomes negative. The reason is this: by balancing technique, we don't need 2x here. So what do? We look for what is called the additive inverse. Additive inverse means that I have a number or a letter, I look for the negative of it. So if this were 2x, the additive inverse of 2x will be what? Negative 2x. If I had negative 3, the additive inverse will be what? 3. It is based on this concept that this left-hand side of the board plays out. So you would have x equal to what? 3. In every equation, the objective is to obtain a definite value for the letter. Come again. In every equation, the objective is to obtain a definite numerical value for the unknown or the letter. So it means that under this condition, x is equal to what? 3. Remember that x is a variable. It has the ability to change form. In fact, if you're watching movies, I'm a strong fan of movies. There's a character I love so much in the X-Men franchise. She's called Mystique. Ability to blend into anything. That's what a variable is. Can blend into anything. The value you give to it is a function of the setting it finds itself. Alright, so we're done with that. We will now go to another question. Alright, we have question 2 on the board, and it says 1 over 2a plus 1 whole number 1 over 4 equal to 1 over 4a. Let me start by telling us here that when it comes to algebraic fractions, keep in mind that we usually use the fractions in their improper mode. So if you have a mixed fraction, your first objective is to try to change the mixed fractions into what? Improper fractions. So let's look at this, mixed number rather. Let's look at this. This will now be what? 1 over 2a. I'm not in a hurry. Let's take it gradually. 1 over 2a plus 5 over 4. 5 over 4 will be the next one. Equal to 1 over 4a. Now, take note that I'm doing this because I want you to understand the things you look out for when you solve problems. The next thing you need to do is to establish your numerator. What I say, establish your numerator. 1 over 2a would mean 1 over 2 times a over 1. 1 times a is what? A, and 2 times 1 is 2. So this becomes a over 2. So understand why that is changing to that now. And this becomes what? Plus 5 over 4 equal to what? A over 4 by that same description. By that same what? Description. The next thing you do is to clear the denominator. That is why the first example we treated, or the first question, becomes relevant. If you understand what we've done here, it becomes easy for you to apply that here. So I will just, by way of saying, LCD is equal to what? If I consider 2 and 4, the answer will be what? 4. There's not much time, but I'll give you a little secret. If you go back to your grade 7, when you were taught LCM, there was an aspect of the LCM that you were taught, and a lot of students didn't pay attention to it. I'm working on doing a video on that. If you catch that idea, you would, at grade 8, 9, you should be able to look at a number and tell what the LCM would be. Look at a set of numbers and just look at them and say, this is what the LCM is, by inspection. It's possible. It's possible, very possible. So the next thing you do here is to multiply through by what? 4. So 4 multiplies this. What is actually happening is that 4 will cancel with 2. So mentally, 4 cancel, 2 cancel 4 will give you what? 2. So maybe we'll do that again. And so now, what I'm trying to do now, I have changed my narrative a little just to help you understand what is happening. So I'm not as detailed as I was in the previous exercise. And this will give you what? 2a plus 5 equal to what? 4 equal to a. Sorry about that. Equal to a. Now with that said, the next thing you need to do is to do what? Collect like terms. The rule is, again, is this. The letters are kept on the left hand side and the numbers are kept on the right hand side. So what you have will be 2a minus a by your concept of additive inverse. That's something you were taught in your grade 8 and sometimes in grade 9. Additive inverse. This crossing equality will change its identity to its additive inverse. And this gives you what? Negative 5. Because when 5 crosses the equality sign, it will change to its additive inverse. And that becomes what? Negative 5. 2a minus a will give you what? A. And that will give you negative 5. Let's note something here. I hear students say 1a. Okay, let's agree. Let's assume that I agree with you, 1a. What is 1 times a? Remember that there's a principle in maths that says that if 1 multiplies anything, it still keeps it at that thing. Is that not? So why not apply that principle at that point? And then what you have is what? A equal to what? Negative 5. So I hope you got that. Let's go to one more question. Alright, we're going to continue by taking another question. I am often of the opinion that there is no particular way of solving a question. I like that approach because it's about decision making. You can't take the same decision for the same kind of scenario and things like that. It doesn't always work like that. If you look at the question on the board, students can take different ways to solve this. A student would say, let's take LCD and start solving. Okay? But I think of something different, and I'm going to use something different here. Look at this. Remember the rule says keep all the unknown on the left hand side and keep the unknown, the numbers on the right hand side. For this question, this is a whole number, this is another whole number, is that not? So I can conveniently do this 5d over 3 minus d over 6 equal to what? 3 minus 1. And I'll be left with what? 5d over 3 minus d over 6 equal to what? 2. It is at this point I will now take my LCD. Now please bear in mind that if you decide to take your LCD at this point, you are not wrong. And maybe you would solve with that same method, maybe in another class, and we'll see that it's still the same thing. But you must learn to increase your ability to make good judgment when you solve problems. So what you're going to have now, the LCD will simply be what? 6. So now, this is what I'm going to do. I'm going to multiply this with this with this. So I'm going to have something like this. 5d times 6 over 3 minus d over 6 times 6 equal to 2 times 6. Remember that this LCD is affecting everything in the equation. So what do you have? 10d minus d equal to 12. And then this becomes 9d equal to 12. So what do? You divide both sides by 9. The objective of every equation is to keep the coefficient of the unknown as 1. The objective of every equation is to keep the coefficient of the unknown as what? 1. So if that is done, sorry about that, should be 9. D becomes 4 over 3, that's correct. 4 over 3. So 4 over 3 becomes the answer to that question. So I want to trust that this will be enough introduction to these aspects. Math is not something you become a guru in overnight. You need to practice, interest and practice. So I'll leave you with this at this point, and will trust that you do your relevant practice, and then when I come again, we would continue from these points. Okay, this is Mamu Wijabi signing out. Trust you go to my channel and have a fun few days. Thank you.